Welcome to Runtime Reverie episode 18. We're barely legal, and today we've got Nigel and Vincent, and how's it going?
Good. Yeah.
Going well.
Yeah, I'm still in Korea, enjoying life here. So
cool.
Life is good. Yeah.
Yeah, how long are you going to be there for?
A little bit longer. Yeah.
Nice.
I don't know yet, but I don't
So
want to
we're
leave. You know, life is so much better. I don't know. Yeah, the food is nice. Healthcare is much more affordable. Things like that.
Yeah,
the quality of life is good.
America's a bit of a second world country, isn't it? But I won't get into politics. You've been working on a game engine. We've got a little Discord group, and you announced that you have just sort of have an early version of that, and it's sort of a number of iterations, isn't it? Like you've done game engines before, and
many iterations. Like before, when I was working in Flash, I already put out the game engine, and eventually, it was Flash was out of style, so it became obsolete. And then when I moved to JavaScript, I started working on different game engines. First using 3GS, so that was like a kind of like 3D base.
It's like a WebGL wrapper, isn't it?
Yeah, it's a WebGL framework, and I think it's used by a lot of people. It's pretty good for not only making games, but a lot of people use it for making 3D projects, demos, and things like that. But even I abandoned that engine because I decided, okay, I just want to touch WebGL directly. I want to be able to manipulate the basics and be able to get the optimal performance as far as I can understand it, because I'm sure my idea of optimizing code might not be optimal, but at least if I know it, I can do something about it. I have more control over it. But then even after I moved to WebGL and I made game engines, I scrapped several of them. And then here's the thing, that I found. When I work on my game engine, and the idea is that, first I'm going to make the game engine, and then I'm going to make some kind of game out of it, and then I'm going to put out to the public for others to use. But I see the same cycle happening over and over. I develop the game engine and I reach to the point where, okay, I get the game out, I got the game engine, but the game engine is so difficult to use because I just get used to coding that way. Then I leave it for a month and come back and what did I write?
Is it web frameworks?
Is that web framework?
Some web frameworks, they have some opinions, and then some stuff's really easy, and then you want to do I just want to do this HTTP thing. I just want to stream this response to something, and then it's impossible, and you're rewriting the framework.
It's more like my own code. I try to stay away from frameworks, so I only use WebGL now. But even the thing that I write myself, I have an idea about, okay, this is going to be very easy to use this API if I design it this way.
So what's your goal in a framework, right? Because frequently, years ago you would talk about things like web frameworks, and people would say the best frameworks were ones where people had just written lots of applications, and in writing the applications you work out which things you keep cutting and pasting from application to application, and you go, those are the bits that really should be bundled together in a thing as a useful set of tools as a framework, right? Is that the sort of approach you're taking, or are you going if only I had this framework, all these apps would be easier to write? And if so, what decisions do you make to say what things should and shouldn't be in the framework to work out what's your use case you're trying to make easy, I guess?
Right, so I think I've taken a different approach over years, but the final one that I have, the one I have right now, I have this particular idea where, first of all, the idea is to make games easier to write, apps or games. I only care about games, really. Apps, who cares? The idea is that I'm going to make this framework, and then people can build templates. And then the template can be, for example, the RPG template, JRPG templates. Because JRPG, they all look the same, you know, like you have a character moving around, they talk to people, like NPCs, they can acquire items and then talk to, and then there's also like, you know, I based the idea of my framework on one game in particular, which is called Fantasy Star, that has dungeon crawling. So I think my first template will be open world plus dungeon crawling, and that would be like that would be my Fantasy Star template. So using this template, you can recreate the game Fantasy Star, and that's pretty much it, you know. Then you just swap the story, swap the characters, and you got a new game. And then the idea is that once you have this template, then you create more template. Let's say you have a shoot 'em up template. So you have a template where you have a spaceship shooting enemies, and now you can combine both in the same game. So you could have your basic game like RPG, and then suddenly you go into space, and it becomes a shoot 'em up. And I think that would be very awesome. But it's getting there is a slow process, really. But I've done it many times. Yeah.
So you're sort of working out like the paradigm or the sort of game style, or like the world of the game, and then you sort of work out, okay, I'm going to be like these. I'm going to have like maybe random characters that sort of, as they walk around the map, they sort of like get generated in random spots, and so you have to like, that's a particular element of one style. Is that sort of right? Whereas if I have a side scroller, like there's going to be like, as I get to this point, there's going to be like 3 enemies at that position every time I go there. Is it that
you asking like, are you asking like how to use the template? Like how are people?
Yeah, what the template is. Yeah, I guess. Yeah.
Oh, I haven't got to that point yet. You know, okay. I'm like so early at an early stage. But one particular thing that I was thinking about the way people are gonna be coding the game is that they're not gonna be writing a whole lot of code. Like once they have a template, they can provide a config file, which is like tons of JSON files just meshed together, and then that's gonna be your whole game. Just the JSON file plus the assets, and that's it. You can just contain the whole game in there, and you plug it into the engine, and then that's gonna be the entire game. There are gonna be some particular moments where you need a little bit of code because you have some idea about mechanics that nobody has ever written before. So you're gonna have to write a bit of code, and there's gonna be a component that is gonna interact with your JSON. Oh, cool. But the main idea is that once we have like a bunch of components written in code, people are just gonna stop writing those little components, and they're just gonna make JSONs to make just a bunch of varieties of games. And
my favorite game writing experience I had was as a kid on the Amiga. There was a bit of software called Amos. And what it did was you could literally drag and drop icons onto the screen, right? And then you'd press, you would just like start playing your game, and it wouldn't do anything. And then you'd press like left on the left key, and it would go, you pressed the left key. What do you want to happen when you press the left key, right? And you'd go, I want to change the coordinate of that character on the screen, right? Make him go left, +1 to the X coordinate. And it would go, okay. And then you'd press right, and it would go, what do you want to do now? And you go, make it go right, right? And then you had left and right working. And then like you'd go press fire, and it would go, what do you want to do? And you go, make a bullet appear, and then set its velocity to this, right?
Yeah.
And then the bullet would hit something, and it would go, these things collided. What do you want to happen, right? And you go, replace them with an explosion and increase my score by 5, right? And you've suddenly got like a Space Invaders, right?
And no code, right?
No, yeah, pretty much. I mean, you had to know like objects and their velocities and things, but almost no code. Yeah, and I loved the experience of like it just detected events occurring and said, is this something I should ignore or do something about? And you just put in the bit of logic you cared about. It makes me think of the those drag and drop programming languages where you can like Scratch, where right, you the world is thought of, instead of having like a main and then like a loop and whatever, you just literally have events that occur, and you go, when this event occurs, run this bit of code. That's just seems like a nice model. But that was lots of fun. I used to write games many years ago on PlayStation 2 and Gameboy Advanced and stuff.
Oh, sick.
As well. So yeah, it always stuck with me.
I think you touched on a very interesting point there. Like when you make the game, and then as you play the game, you can actually like add to it, right? Because like the event is happening, and you detect the event, and the game is still running, but you can still iterate on it while it's happening. And there's not many apps or games like that exist, right? Where the thing is running, and then in the middle, as the thing is running, you just want to evolve it somehow. You know?
Yeah. Like Visual Studio used to have this concept of stop and continue, so that you could you'd be writing code, you'd be running the code, you could put a breakpoint in. When it hit the breakpoint, you could then modify the code and then like continue, and it would run your new code, right?
Yeah.
And that was a really fundamentally useful tool. And then C# took it away. I think it was in C# as well. It was definitely in C++, but I think they took it away again after a certain level, like a certain version. And they went, oh, yeah, we can't support that feature anymore with some new feature we've added to the language. And so the feature disappeared. And it was...
That's kind of sad.
It was shocking. It was so sad. It was such a step backwards, right?
Yeah. I tried that in Xcode with, I think, Objective-C, and I think I remember it not working, or not working quite right. So I just had to do like a full build and kill it, and then build and run. Like it was like one of those things that they had on the slide. You go, wow, that sounds awesome, and I just like didn't quite live up to it.
Yeah, right.
Like maybe it's just like very technically difficult, and eventually like you have to stop supporting it if you want to add something new, because every time you add something, then it makes it so difficult as possible.
Yeah.
Erlang has this as well. Like I'm writing a lot of Elixir nowadays, and Erlang has that sort of like Elixir is built on Erlang, the Erlang virtual machine, and sort of it's got the sort of concept that all code is just really data, so you can like hot swap stuff.
Oh yeah.
So they used to use that when they had it at running telecoms, was that the server would just be running, and then they would just go, okay, here's the new version, swap it over, and then it would just load up the new code. So, but I think it's quite an art to actually have that to to make that dance work.
That's one of the things that I want to incorporate in my game engine. The idea that code is simply data. With the idea of config file, like I was thinking, like it would be even better if that config file you can actually modify it even as the game is running, and then suddenly you have your new mechanics,
That's
in
cool.
the game, or new things happening.
I'm curious, Vincent, if in terms of like I think the naive version of when you start writing a game, especially if you come from the world of object-oriented programming, is to like model everything as an object. Is that so? And then I've read some stuff where they say no, don't do that, and I'm forgetting the name, but they have this sort of like basically a big array of the object data, and they sort of work on that every frame, like every loop of every iteration of the loop.
Oh yeah.
Is that what's the sort of patterns that you found there that you like?
Not sure exactly like the way what you're mentioning, but I think one of the things to touch on when you work on games, and I guess Nigel, I guess you can also correct me on that, but like you kind of like have to not completely think about object oriented, because object oriented, they don't. There's not like so much care about performance, so creating and destroying objects like willy nilly, that's like kind of commonplace, and it makes the code clean or things like that. But in game, it's happening every frame. So if you keep creating and destroying object every frame, that's really, really bad for performance.
Because you've got the garbage collector as well, right? It has to
collect. The garbage collector, like as you play the game, suddenly like, oh, I have this bunch of things I need to garbage collect, and then the game freeze. That's not very good.
So in games, you frequently find a way to try and work around garbage collection if it's there. Actually, like allocate some big buffer, and you do your own memory allocation within that from then on, right? But then you still have to like run the garbage collector running every so often.
Well, there's this idea about like object pool, basically you just create a bunch of objects, and then,
like
when you don't need them,
like a bunch of enemies or something, right?
Yeah, let's say you have. I think it's very useful when you have bullets, coming out. Because you don't want to like keep creating the bullets, and then when the bullet is out of the screen, you don't delete it. You just like make it disappear, and then just put it somewhere, just disable it basically.
So you basically
and then you can recycle.
Yeah, okay. You recycle. You're putting them in the recycle bin. So instead of and so the next bullet that's fired, it looks the same as any other bullet. It just
you just grab it again, and then you just change the direction, and that's it. You have a new bullet, exactly the same. You either do that iteratively, so whenever the object destroy, you have to remember to put it to the bin, and then when you need a new object, if the bin is empty, you create a new one, but if it's there, you take it, and then you just keep creating stuff like that. So there's another way of doing it, where every frame you just create a bunch of objects, and every frame you destroy everything, but you just store it, and the next frame you just grab everything that you put on the side, and then you just reuse it again.
Is that something you'd bake into your game engine? Would that be into a user of your game engine, or most game engines? Would that be invisible, or is that sort of something that you go hey, you just created a new enemy? Maybe it's got some stale data, or is it sort of wiped clean, or how does that sort of work?
Well, are you asking if in the game engine it would be automatic, or is that something the user would need to think about, or?
Yeah, you go.
Yeah, so if you wanted to do a bullet sprite pool where you're going, oh look, here's my bullet objects. Here's an array of bullet objects. I'm going to have 500 of them at any one time. Do you just say that to your framework and go, to your ideal framework, I guess, and say that's a concept I'd like to have available, or is it something that you go, that's a technique that developers need to be aware of and to apply?
I was thinking just hide that from the developers, this whole all those techniques, they might not. I mean, it's good to know that, but it's not something that you really need to think about. I want this thing to be able to appeal to artists, and then artists, if they start thinking about object pooling or things like that, that's gonna be terrible.
Yeah, because I was thinking, if you had a bullet and then maybe the bullet hits a surface or something like that and explodes, and so then it gets retired. But then when you pull that bullet back up again, you don't have to go make sure to unexplode it, because you could just easily forget to do that. So
sure.
Yeah, but one thing though to enforce this kind of idea is that I want to make sure that at least let's say people want to create bullet okay, I'm gonna have object which is bullets, but they're gonna have to specify the maximum bullet that can exist in the world, because if I don't put a limit and they just keep creating stuff like crazy.
It'd be a great game, unlimited bullets. It'd be fun when we just
not too sure on the screen. That's gonna destroy your computer.
One of the games I was working at, when you shoot a wall, right, it leaves some sort of decal behind, some sort of mark on the wall, and one way to do that is to effectively have little images that you've splatted on the wall against the wall that are slightly offset in front of it, so that you don't get Z issues, but you can only have a finite number of those, right? And you'll see that in games. If you stand and shoot a wall, eventually shooting a new one makes a previous one disappear, right?
Yeah, the bullets suddenly disappear from the wall. Yeah,
it's a first in, first out queue or something. The first bullet thing. Yeah,
exactly, right?
Disappears.
Yeah, so that can work. But another way you can do it is you can actually affect the texture itself. So that if you've got if you duplicate the texture and then literally write to it whenever the decals are right on it, then it can sort of permanently change.
So you can actually have infinite markers on the wall because you actually change the image then.
Yeah, we had this idea too of making decals with the alpha channel set, so that you could effectively shoot holes in things, and then and then you could see through them to see what was through the other side.
Good idea. Dude, you're giving me so many ideas for the game engine. Now I'm going to reuse all that.
Absolutely.
It's kind of crazy games if you think we think us as app developers have such a hard time, but if you think of games, it's literally people are just running around bored or just playing with stuff, trying stuff out. There might be a player who just will literally try and shoot every single surface in the game, and it has to not crash, and that's normal.
In a first-person shooter I was writing, we had a pool table in one of the rooms, and so the level designers had put pool balls on the table, then sure enough, the testers came back, a little while later with, hey, there's a bug. If you spend enough time shooting the balls, then things go haywire. I mean, they're like, who's going to spend 2 hours just shooting balls on a pool table?
Oh, this is dirty. I like how she had like actual pool stance too. She's like down low, even with the table. Look at, still going.
She's gonna look like a much better shot than me.
I'm feeling it. Oh.
You're going, like, yeah, a lot of people are going to try that.
Yeah.
It'll be named in the It'll be named in the IGN review as the one of the bad things about.
Yeah, they're going to try and play a full game of pool, aren't they? Just know it.
It'll become a spin-off game, where it's just shooting pool
using
balls.
a gun.
Yeah,
I love
I'll
that.
try that. Yeah.
So fun.
So I was wondering, Nigel and I were listening to. Nigel introduced me to this podcast with. It's called Software Unscripted. It's episode 78. Things web devs can learn from game devs with Casey Muratori, and he had some strong opinions, but he was also talking about some of the similar stuff. Like one of the things was that idea of having hard limits, and sort of working out ahead of time. Okay, there's only like 500 enemies ever, and so you can't just sort of dynamically allocate
New ones.
Yeah.
We can't dynamically have that many enemies in the game, but then also like from a memory allocation point of view, you can't just sort of like allocate until all the memories like used up in the game. So like, because there's so many different dynamic things in games, if everything sort of could just sort of eat up all the resources, the game's just going to crash. So you have to put like, it sounds like you have to put like limits everywhere. So I thought that was really
It's funny actually. We used to have in C++, we used to have our own memory allocator that would, when it started the application, it would allocate a chunk of memory, which it used as its reserve effectively, and then it would have game memory. And then if for some reason the system tried to allocate memory and it crashed and ran out, like normally you're dead at that point. But this would then have the ability to eat into its spare buffer, allocate that extra thing, but then start going, hey, look, we're out of memory. How do we handle this? How do we roll back safely? How do we save the save game? Like, how do we persist the state so that we don't screw the user over?
As in, like you'll still crash, but you'll sort of crash gracefully.
Yeah. That was
So you
the
try and
basic
save the
idea.
game quickly. Okay, the ship's sinking, so let's try and get the people in the
Exactly.
lifeboats.
Yeah, it gives
And
you
then-
that buffer to go. The ship's sinking. Let's do something about it.
That's a lot nicer than Word or Excel, where when it crashes, I lose all my work and I got so pissed. Like, what the hell? I remember, one time I was a TA in school, and a student had the Excel crashing, and then they were in panic because they would lose all the work, and then somehow I forgot how, but I think I was able to debug have Visual Studio hit the breakpoint, and then just modify a little bit of random stuff.
Oh my god!
And then it went through, and I don't know. Okay, I said save the thing, and then just close the thing, and then it actually saved the work. It was kind of amazing, but. I don't know, but that was random luck. There's no way this happens in the no.
Simon's not here to defend his hard work, by the way.
Oh,
I'm used to work on Excel, so
that's true. Yeah.
When I was doing Game Boy Advanced games, the team I was working with had done this awesome thing. The two of the guys had written this Game Boy Advanced emulator, which we coded against. So you can compile for Game Boy Advance, run it on the emulator, and run your game.
Emulator's
on your PC.
like a computer or something, or
Yeah, so on the PC you could run the Game Boy Advance code. But one of the side effects of that was the testers could run the code through an emulator too. And what the emulator was also doing as it ran was remembering every non-deterministic thing that occurred. So every key press, every random value that gets generated, anything that was needed, that you could then replay that log.
Oh, wow.
And it would replay the game as if you were playing it. So it remembered, if you've got physics and things, then the physics will frequently depend on the frame rate of the screen.
Oh, wow.
So because you go, if the frame took this much time to calculate, then this much time elapsed, therefore the bullet should move this distance, right?
Wow.
You have that sort of thing going on, right? So this would remember the frame rate, the frame distance is as well, right? And things like that. Anyway, it logged enough information that you could replay the log and get the exact same experience that the tester had, which meant that there's a couple of cool things. One was you could replay it and turn the screen off so that you didn't actually need to render, but it would still behave exactly the same way.
Oh, wow.
And the other thing was that you could then go, okay, they played the game and it crashed. They would take the log and send it to you and say it crashes. You could literally go replay up to 5 steps before the end of the log, right? And it would go, and then you just press start from there, attach your debugger, and go step, 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 bang. Oh, that's what's wrong. So awesome. that feedback loop cycle was fantastic. And it's interesting. I saw a talk a while ago about someone just talking about logging in applications and was just saying, if you imagine your code base split into two halves, there's the pure functions that are effectively deterministic. So whatever that goes in, that you know what you're going to get out. And then there are bits of the code that are non-deterministic, right? Like you ask what time is it or something. And so as a result, you end up with, if you have logging around all the non-deterministic stuff, like a user typed something or, some random number was generated or whatever, if that's the stuff you log, there's no point logging the rest because it can be recalculated.
Yep.
So you end up with this log of all the things that were non-deterministic. And that's all you need to be able to replay it again. So it's basically the same premise, right? You end up with only log the things that you can't calculate, and you log all those things, all the things that you can't calculate, so that the whole thing's replayable. And you end up with this beautiful development environment as well, where you can just take logs, rerun them, see what went wrong. I haven't done. I've done it on PlayStation 2. I haven't done it in any industry other than games though.
I think it's kind of the same technique in some of the game like Braid, where you play a game and then you can actually rewind and then have the game play itself again and with a second character. I made a game like similar to that, where you can replay your own game again, like with a second character.
Yeah, there was a guy that did some tech demos about about the time Elm was coming out.
Yeah.
Because Elm has that, like, here is my state, here's my update function, here's my render function, right? And you go, given an event and my state, give me a new state, and then render it, and then you just repeat, right? So it has time traveling debugging. So you can say, let's roll back time and let's go back through the states, back to previous states, and then step forward again, right? So, but there was a guy that was showing, there's a tech demo, maybe we'll find it and put a link to it, but he was doing things like running along a platformer and then jumping off and missing the thing, right? So then he would just change gravity, and you'd see like a projection of where he would end up going,
That's
like
crazy.
changing, until you go, that gives you the right jump. So the level designers could play with variables like in real time to change. I love the idea. It's so good.
That's
anyway.
Awesome.
Yeah.
And
I'll find the link, put it in.
It's interesting to contrast to like some of the, just thinking of it as a web developer, like there's this thing called PostHog, and there's other commercial ones as well, where you add it to your web app, and then it records everything that the user's sort of seeing, every click that they do, all of that stuff. But it's not following what Nigel was saying. As far as I know, like it slurps up all of the HTML that's ever on the page, like basically after every single event. Because, you might open a modal, so it goes, okay, well, I'll slurp up that HTML as well. And then, it captures all of that data and then sends it down a WebSocket. And I always feel like surely that must slow down the user experience a bit, because it's like if you're on a mobile phone on 4G and it's having to send all this, basically download the website and then send it back up again, that must slow things down. So if you architected with that in mind from the start, it'd be much more efficient. But there
was sorry, talking about games again still. There's some algorithms that they use that are just really awesome, right? Like one of my favorites was you've got two people running around in a platformer, right? Or in a first-person shooter. Okay, so you can see the other person moving and they can see you moving. So you need to have a way for your computer and their computer to share the coordinates.
Oh, is that like over a network or something?
Two people. Yeah, over a network play, exactly. Yeah. So what you need is some way to say, is to know where the person is frame to frame to frame to frame, right? So one thing you can do is to try and predict where they're going to be next frame, right? So you go, and a good assumption for that is they're going to keep going in a straight line using the same velocity they had previously, right? Now it's going to be wrong at some point, but and so you end up with like where you thought they were, then you get a packet telling you where they actually are, and you go, oh, and you have to move them to where they actually are. So you see people jumping around, right? That's not ideal either, right? So one algorithm I heard about that I thought was awesome was you have you know how to predict how people are going to move. So let's say they're going to continue in a straight line. The other person knows how people are going to move, predict. You know what algorithm they're using to predict, right? So you know where you are. You know when you told them your location last, right? And you know where they think you are because you know what they're going to use to predict where you are, right? So if someone's a long way away from you, you don't care so much about where they are. Like as long as they're within a few meters of where they actually are, that's fine. But when they're close up right next to you, you need to know exactly where they are, right? So what you can do is you can only send your location to people when you are.
Oh wow!
When you know that the error between where you are and where they think you are is big enough and significant. Does that make sense?
Yeah.
So you can drastically reduce your network bandwidth.
So basically, like when you make an action, then you know, okay, they don't know I did an action to turn left, so I need to send them something so that they will know, right? Or something like that.
Yeah, because you go, I know they think I'm going straight, but actually I've turned. But that's fine for the first few frames, but by the time I get to the fifth frame, right, I'm far enough away from where they think I'm going to be that they really should have a new version of my location and velocity and whatever.
And it might, like, if you, like, it's a game where you have a sniper, right? Like, if as you zoom in on there to get the headshot, like, then you'll start to say that they're close again. So
exactly, yeah. They're zoomed in, therefore they need to know more or something. Yeah, absolutely.
What's that concept in games, where you have the sort of objects, is that it's really detailed as you get close, and then as you get farther away, the geometry gets simpler?
Yeah, levels of detail. They're LOD levels, yeah.
It's sort of like, sort of like that? Yeah.
Yeah.
Fascinating.
What I find fascinating too is, so I was working in one games company, and a game came out and it had an infinite draw distance. So like everything looked beautiful no matter how far away it was, right? And prior to that, people were complaining and saying, "Oh, you can't do that. You've got to have you've only got a certain number of." Yeah,
like GTA San Andreas did a very clever thing with its map where it sort of felt like that, but they put mountains and stuff in the place so it never quite.
Yeah. So games were or just like adding fog, right? So you go if you can't see past a certain place, it just gets foggy, and then you can't see into the distance, right? Because they can't draw everything, right? So someone came up with this idea of having effectively billboards, right? So you have this virtual billboard that you place in the scene, and on it the texture is what the camera would see going through it. So what's behind it rendered onto an image, right? Crazy. And you just place those around the user, and so when they look around, it looks like they can look all the way off into the distance, but in reality they've got these billboards.
But those are static. Then nothing has to change. Okay. Yeah.
Right, but they're you can update them on a certain frequency, and then depending on how far away they are, the resolution can be different. Anyway, but basically there's this technique, right? And the funny thing was, like, I was talking to some of the more technical guys about like how to do this sort of thing, like how could you improve the draw distance, and they were all going, "Oh, it's not possible. It's really a really hard problem, very difficult to do." Then a game came out that could do it, and without looking at the game or any of the code or any of the implementation, some people went, "Oh, I know what they've done." Wow! And you're like,
really?
If you just thought in your mind, this is possible.
Yeah.
You would have worked it out, right?
It's not possible until somebody do it.
Exactly.
It's like in the 1950s. I'm probably going to get the thing wrong, but I think there was like a 5-minute mile or 4-minute mile or something like that. And there's like this record that no one had ever done it under 4 minutes or whatever it was. And then
it's just not humanly possible.
Yeah, it's not humanly possible. Then someone did it in 1955, and then like after then, like a whole bunch of people like got under 4 minutes. It's like, this is crazy.
Yeah.
By the way, which game was that, Nigel?
I was working on Ice 9, I think it was called. It was a PlayStation 2 first-person shooter. Yeah.
We should
Okay.
totally.
But I don't. Sorry, that's what I was working on. I don't remember the name of the game that had the billboards. I don't remember. It was many years ago.
Oh, okay.
Long time ago.
I'm sure there's some conspiracy theories where people think that's happening in real life. By the way, like the Truman Show. Could be. Look out the window. Look closely.
Yeah.
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 Sweet. It's kind of interesting. Like I used to have this idea for a MUD. You know, multi-user dungeons. Those sort of text-based adventures where you run around. Have you not played those?
No.
So like you go north
I've
and
played
it
some.
goes, you see a sort of, you go east.
Yeah.
Those games?
Yep.
Yeah. Okay. So those
had-
sort of text-based.
They always had really good
games.
draw distances, didn't they?
They
Yeah.
did. Real exceptional. Yeah.
Your imagination was just infinite.
Yeah. And there was one called Mud 2 that was around when I was at uni a long time ago. And it was like the best. It had some really interesting ideas in it. But I loved the idea of... Okay, so I had the idea at the time. This is a complete tangent, right?
That's good.
That the AI that you're talking to, right? You could sort of interact with the AI because you could sort of have these fixed conversations with it. I'm really fascinated with the idea of LLMs being used to have, like, being trained with the understanding of the environment they're in, like it's a reality. Like this is like, so they don't need to know everything that we know.
It's like the background story.
Everything.
It's like an actor being given the background story for that character.
Exactly.
Yeah.
Yeah. And they shouldn't know about Elon Musk or whatever, right? But they should know about how physics works, like things float and things sink, right? At least to some rudimentary level, so that you can have those sort of conversations with them. Yeah, it's interesting. Anyway.
Yeah, I think like some games they've been starting to use AI, and then like some players they've been making videos about them talking to NPCs for a very long time, and then like sometimes they feel like they really are having a conversation with a real human, and then at some point, players, what they really love to do is tell the AI that they are NPCs, like you are not a real person, and then see how they react. And then some AIs are in real denial, and like it's a little bit crazy.
It's like those fake villages where people have to pretend to be the person from 1788 or whatever.
Yeah. I went to there's a place I'm in Melbourne, Victoria. There's like this castle. There's this place up north a bit that does medieval reenactment and other sort of reenactment things. Mm-hmm. What's the one? Sovereign Hill. Have you been to Sovereign Hill?
I've never heard of it.
Okay, so it's like gold mining area, and it's been set up as if gold mining days. So you can wander around the streets and go to the shop that makes traditional lollies, and you can see all the equipment they use for gold mining, and they have like an old bowling alley with the wooden little bowling thing. It's just, and lots of like metal work and stuff like that. Anyway, it's a bit of fun. Schools can go there, and they have the kids like enroll in the school there because there's literally a school there.
Wow.
And they spend the day as school children of that time period. I went there with a homeschooling group, and being one of the people looking after the kids, I ended up having to dress up in garb and walk around town as well. So I was in appropriate period dress, and they're really strict about like don't interact with people, or if you do, you have to stay in character, sort of thing. So it was. So I had my photo taken with a bunch of tourists and stuff. But
a black and white.
Yeah, because I wandered around town, and tourists would come up to me and try and take their photo with me.
No, I'm just kidding. I'm just kidding.
Oh, photo, yeah.
Your character be like, "What is this? What are you doing right now?"
What is? Why are you pointing that at me?
Yeah.
Where's the guy with the hood and the flash thing?
Yeah, exactly. Yeah, they should do that. Have one of those things, and it's just an iPhone. And then
That's brilliant.
And then the smoke goes off. Yeah.
Should be given one of those when you enter, and then you can carry it around with you. That would be so good. Oh, that's so funny. Yeah. Anyway, I don't know how I got into that. It was
That's
lots of
awesome.
fun. I really enjoyed that. I really enjoyed playing the role. Yeah.
So that's what it is, in games, the AI characters, they know about everything, but they just have to stay in characters. They are aware of everything that's happening. They're sentient. Yeah. but they just like for the player, they have to pretend, yeah, I'm in this world, yeah, whatever.
Awesome.
I'm kind of convinced, I don't know, that there was a few articles at the start of the year because ChatGPT had just come out and the Bing, whatever it was called, had just come out, and then people were like testing it, and then it seemed like they had a really strong personality when we're kind of like quite deep and like. But I was sort of wondering, do you think they were just trained because it's just been trained on everything? There was an interesting thing. Elon Musk spoke at a conference, like a thing, and he sort of said, what we sort of already knew. They just have trained on all copyrighted data. They haven't been very careful at all. They just want to get an advantage. So if they get sued, they'll just get sued next year. But they've already dominated. But yeah, I've wondered if they were just trained on like dystopian novels, and so that's why those characters were coming up, because they were trained on like sci-fi novels where there was an AI that was sort of having an
belligerent.
having this crisis. So yeah,
that's cool. Well, taking us back to something we mentioned earlier, right? You said about having arrays of objects in memory. I've recently been looking at the Zig programming language, and one of the really interesting design concepts they've got there is this idea that you can go. It's like a C++ type language, or a C language, really, more like a C language. But you can have structs, and then you can have methods that know that their first parameter is that struct, and therefore they feel like methods on the struct. But having structs, right, you can decide how you store those in memory. And one of the things that you can do with an array of objects in Zig is to say, I'd like this to be stored as several arrays of properties as opposed to arrays of the structs themselves. And that means that you can have like all the usernames in an array and all the passwords or whatever, all the ages, all the heights and whatever as their own arrays. And then that makes some calculations much more performant because everything's in memory and you're looping through that list. It's like far more likely to get a cache hit because you've preloaded the right stuff and the next value you want is already loaded in the cache and so on and so forth. Because
it might be, one of the fields of the struct might be like is enemy or something, like for a game, or I don't know whatever this flag is wizard, and then like what it might do, right, is put that into like instead of having that as like it has to expand that usually to like a byte or like a 32-bit field, or it can just put them all in like have a massive like bit set, right? Like just go like there's actually just one bit for every single like enemy, and then just go, okay, is wizard, it's just going to do the sort of logic to find that.
Yeah, so rather than having a pointer to the struct, you end up with effectively an index into a set of arrays, and so But the really nice thing about it is that in your code you don't notice the difference. It's like it's a concept that's hidden behind an implementation.
Compiler magic, yeah.
Exactly.
Is it? I haven't got any experience with them, but is it sort of like that idea of like a columnar store database? Like
It feels really similar to that, in my mind at least. Anyway, I'm learning this stuff. It's fairly new to me, but yeah. There's a couple of other things I really like the concept of having compile time code, so that you can mark code as compile time, and then things like the type system can go, okay, well, if I know that at compile time, then I can infer some stuff when I'm compiling the rest of the code. Is really interesting. So that gives you concepts like generics. Something equivalent to generics just works because you write functions that take a type that is compile time set, and therefore it can infer the rest of the methods from that. The more I think about it, the more things like that, like regular expression parsing, right? You've typed a regular expression in your code, right? At compile time, it could go, well, that's not changing. It's a hard-coded regular expression, right? Why would I restore that as a string and then have to interpret that every time I use it? Why wouldn't I compile that to something? Yeah, because it's like a little state machine that gets run within the code base.
Because then you have to have this sort of like universal regular expression parser and executor bundled in the final result, whereas if you're just going, actually there's this one regular expression that's just testing if it's got an ASCII character, like you can throw all that other stuff away and just do the whatever that actually needs.
Yeah, so it would compile down to some sort of if,
Yeah. That's cool.
It's that's awesome. But more and more I think about it, like when I was doing C# code a lot, we used dependency injection frameworks to help to split the code base into almost like a bunch of reusable building blocks, and then the wiring code that would plug those building blocks together. And that gave you this really nice sort of, we had like an internal DSL for the wiring side of things, and it effectively came up with like a description of your architecture. Because you'd say, I need one of those, one of those, one of those. They all plug together in this way. And then this has a factory for a subsystem that does this, and right? And the thing I always struck me was I really liked that design, but a lot of that wiring stuff, right? That's all hard coded, right? So there's a hit when you start your application up that it has to execute the wiring and go, okay, well, I'm going to make one of those, one of those, one of those, put those together in this way. Like it has to do that before it gets to the point where, and now everything's standing up, we can start, right? If I made that stuff in Zig, I could do it as compile time code, and that way, all of that wiring could evaluate down to what is the essential memory allocations that have to happen and before you can start, right? And it wouldn't be
statically allocated. Yeah, that was one of the topics of that podcast. So
you would just end up with
it's
at
sort
runtime the code would be much simpler, right?
It's sort of this analogy might fail, but it's sort of like, hey, we've got this, like, we're doing this massive play, and it's going to be like 20 angels, and it's going to be like 50 orcs, and I don't know what this play is, but there's going to be 30 soldiers and whatever. And it's like, let's, instead of going like every okay, soldier number 3 come out on the stage, soldier number 4 come out, like you just have them. Well, you've got 40 soldiers, and then you've got you just
the way I think about it is more like the way the code was designed. Effectively, you had like a Lego set. You had all the building blocks, and then you had the instruction manual that said this is how you put the model together, right? And you couldn't play with the car until you'd assembled the model, right? And half the code was describing that manual and assembling the model, and then you could play with it.
And that's what sort of classes were supposed to be, right? They were your instruction manual in a way, weren't they? Like that's one way of thinking of a class.
Yeah, sort of.
You're going to create this object, and then here's the description of how to create the object.
Yeah. So
I guess yeah.
That's right. I'm trying to work out how that fits in. But in my mind, effectively, what I'd like to be able to do is make the assembly of the model from the building blocks compile time, so that when you press start, you're starting with a Lego car that's pre-made, not building a Lego car and then starting to use it. Yeah. Anyway, so I think there's an opportunity there for more and more stuff being done at compile time that you can just write as normal code, and yet you just say this is compile time, and it goes, oh, in that case, I'll get the compiler to simplify it all before the executable ever gets created.
Yeah, basically for every application, there's always like some step where things that get put into this world, right? But actually, this whole thing ends up as a block of memory, and that block of memory is always the same for every application. So I guess what you could do is just like have it preset and just bam, put it there, and then
it's sort of like
totally.
I don't know if anyone does this. It's probably a really dumb idea, but it's sort of like if you had a game, and then like you can save the game at any point, right? It's like you started the game, immediately hit save, and then just took that save file and just made everyone load that save file instead of having to do all the other sort of usual code.
Well, there was a really interesting. There was this talk someone did at I think it was at Strange Loop recently, where they were talking about these little demos where they were saying, like, if you've got like a movie and you like this little bit of the movie, then you can like cut that little snippet out and go, here's that snippet of the movie. I love that little bit of the movie, right? They were doing the same thing but with computer games. So they would record that little bit of a computer game in such a way that they were I think these were emulated games, but they were using the fact that they could tell which bits of the code were being executed when that bit was running, that they could then shrink down the executable of the entire game down to just enough code that would run that little bit of the game, right? And then save that as its own little file. And not only that, they were taking that binary executable, encoding it into pixels in an image, and then attaching those to the screenshot of the start of the game, right? So they had a snapshot of the beginning of their sample, encode the binary into that, such that you effectively had these images that when you, with the right interpreter, it would literally play from the point on the screenshot onwards for a period of time. So like you could finish the level or whatever you were trying to do in that bit of the game.
My mind's a bit blown.
Insane, right?
I'm not sure if I quite understand because like
I think so. The idea is basically like at the end you have a image that's just an entire mini game, just the image itself.
So
you've got an image, and then when you can effectively press play on it, and then start interacting with it and moving your character around on the screen or whatever.
Within the image, there's bits that represent code, right? Or like pixels that represent code.
Do you mean image as an image of like data, or do you mean image as like a picture?
Like a JPEG or not a JPEG, but
JPEG is gonna like make
that would lose data, right? A non-lossy image.
Because you could just capture the pixel. You could just capture the pixel buffer, right? Like if you normally record a game, I imagine you just capture the pixel buffer, capture the audio coming out of the game.
But then you don't have the physics.
This is
right?
one step further.
This would still allow you to interact with the game and move your character left and right and jump and all the things that you would normally do in the game. It's insane. Anyway, I'll find a link to it. But I was watching all those Strange Loop videos because they were just very eclectic and yet really interesting. Yep. And so I was watching ones that I wouldn't like. The title didn't grab me, and then when I started watching it, I was like, that's so weird. What a really interesting idea.
I'd love to be able to work at one of those game companies. They look fascinating. Like some of the stuff.
This was a research project, I think.
Yeah, right. So cool. Should we wrap it up? So I think we've decided, Vincent, that you're going to throw your game engine away. You're going to rewrite it in Zig, and
yep.
You can always compile it to WASM to run in the browser if you want to run in the browser.
It's gonna happen eventually, you know. Like it's a cycle that keeps happening. So I don't know.
Vicious
circle.
The only concern I have with Zig at the moment is just the standard library doesn't seem to be completely there yet. There's some things that you would expect to be there, but you can always rely on C++ if you want to. So
I know C++. I've plenty of C++ these days. I'm like,
well, the Zig compiler is also has Clang built into it. It's literally a C compiler as well, and a C++ compiler. So the interop is insane because you can literally just compile the code. Anyway,
is it C++++? Is that what it's trying to be?
Is that what Zig stands for?
It's taken. If C++ was make any existing C code work, but add some extra stuff, it's like, well, let's do that one step further.
Yeah, it's good. Anyway, I'm still learning. It's fun learning experience. All right. Okay. Well, let's wrap it up, guys. It's been
it